everybody. It's me from home, and today I'm going to take you on a little journey into color theory and color mixing using the color wheel that we have in the classroom. I have two of these hanging in the classroom. Hopefully they're familiar to you. You might have seen them. I'm going to be going over a lot of information, and I'm going to be going fairly slowly, so please bear with me. Some of you may not have had this type of instruction for quite a while. Some of you may have had it just a couple of years ago, but refreshers are always good. Okay, so this is our 12-point color wheel, and there's 12 colors on it, obviously. We see there are 3 colors that are connected by a black line. These are called the primary colors: red, yellow, and blue. In between the primary colors, also kind of a largest circle, we have 3 colors that are connected by a dotted line, and these are called the secondary colors. They are orange, green, and violet. Violet and the word purple can be interchangeable, but violet tends to run off the tongue better when we're talking about color. The purpose of a color wheel is to show us how these colors mix together. The reason why in color mixing that the red, yellow, and blue are called primary colors is because these colors cannot be made by mixing. That is quite important to remember. They are the first group of colors, and they come from natural materials that have been discovered over thousands of years of experimentation. And just for example, you might want to just know about some of the things that can create these 3 primary colors that have been used over the centuries. Just in your home, onion skins can produce a yellow if you wanted to make a yellow dye. Red actually comes from a beetle called a cochineal beetle, and much in production still today. They like to live on prickly pear cactus. Blue comes from several different kinds of locations, and a lot of them are quite poisonous because they're minerals and chemicals. But here in the United States, indigo, which can be grown in the southern states, can produce a blue pigment and a blue dye for making blue things. There are different ways to make paint. I'm going to be talking about that later on. But the paint that we're going to be using for demonstration and in the classroom when we get back to it is called tempera paint. When you take the primary colors, you can mix them together to make the secondary colors, and they don't necessarily have to be in equal amounts. That's where your trial and error is going to come in. You're going to try to get it as close to an in-between green, orange, and violet as best you can. You would take yellow and you would add blue to it to create green in small amounts. And I'll be demonstrating that later. Red and blue make violet, and red and yellow make orange. You also see a group of 6 other colors on the color wheel. These are called the tertiary colors. Primary means first, secondary means second, tertiary color means third, 3. You can even go even further, we just don't need to do that here. And you're going to notice that the names of the colors on here, if you can see it, are just your basic colors. Nothing fancy, no magenta, no fuchsia, no lemon yellow, no goldenrod, which I don't even know if that exists anymore. But the names of colors that you see in a crayon box or for marketing purposes is just that. It's to get you to, buy them and to recognize them as a unique color. But basically, they're just a primary and a secondary mixed together with the addition of black and white. And that we come to gray. You don't see black and white on the color wheel. You don't see brown on the color wheel because the brown is a unique color. Black is a very basic pigment that comes from several different sources. But if you think about it, anytime you burn anything, it turns black. That's a good way to remember. Carbon is about as black as you can get. And then white in pigmentation is the absence of color, meaning we don't see any pigment, we don't see any color. When you mix black and white together, you get gray. Well, wait a minute. What about light blue? What about pink? What about sky blue? Those are variations of all of these basic hues, these standalone colors with white and black added to them. When you add white to a color, you're creating a tint. So, pink is a tint of red, or it could be a tint of red-violet, depending on the mixture. Sky blue is a tint of blue-green. Lilac can be a tint of either any of these three colors, depending on what kind of lilac you want. Navy blue is what we call a shade. A shade is a color with black added to it. Olive green. That's probably yellow green with a lot of black added to it. So again, you're just taking these basic hues, these pure colors, and you're adding either white or black to create tints and shades. I have this little chart. Grays create tones. We have different kinds of grays. You can have a light gray with some color in it. You can have a dark gray with some color in it. And gray is created by adding those two additives together, black and white. Brown is very interesting because it's all the colors of the color wheel joined together. Red, yellow, and blue make everything else. So if you take red, yellow, and blue and mix it together, you're going to get brown. What kind of brown depends on the combinations, how much of each color are in it. And I'm going to be demonstrating that later. So that's how we mix colors together on the color wheel. It's very, very basic. Okay? And again, I'm going to be demonstrating it with actual paint later. Now I just want to talk a little bit about like the physics, the science. You got to kick it up a notch. Okay? Why do we see color the way we do? Well, inside our eyeballs we have certain cells called rod and cone cells, and we have them in combinations with each other. Sometimes you can be considered colorblind if you are lacking in one or the other. Okay, it's the combination of what you have. Unfortunately, most males are colorblind, although females can be the carrier of the gene that causes it. In 15% of the population, or thereabouts in the world, there are people that are very acutely able to see the slight differences between color. Or they can make the differentiation between similar colors very easily. Like the difference between yellow and yellow-orange if somebody's mixing it. I kind of happen to be one of those people. I can tell the differences when you guys are mixing colors, you know, if you're on the right track or not. If you were to do this in class, my expectation would be that you're just making a very, very close general color close to what you see on the color wheel or some of the other examples. I'm not expecting everybody to be perfect right off the bat. I just want you to be able to understand what to do. So again, I'm going to put up this little you can see from that little chart that when you add gray to a color, it makes a gray tone, used highly in interior design and clothing design. And when you add brown to a color, you get earth tones or brown tones. And again, very much prevalent in home interior design and clothing design. So, color is all around us. It can be an emotional thing for some people. It can be very sterile in certain instances. There's definitely emotions and psychological processes assigned to certain colors. So it's a very, very interesting field to work in terms of saying you're a colorist. The way that color works in terms of, science and physics is white light, that coming from the sun. If we break it up, we see the colors of the rainbow. We see red going into orange, going into yellow, going into green, and then finally violet. We also see that it's always in the same order. If your color wheel isn't in the same order, just like the rainbow, it's wrong. There's something wrong. If the rainbow isn't in the right order, there's something wrong with the universe. All right, so a very important thing to remember if you're making a color wheel is that it needs to be in order. When the color enters or hits an object, that color is bounced out of the surface of the object, and that's what we see. That's what we perceive. So if you have a nice red delicious apple, all the colors of the rainbow are hitting that object, but whatever that apple is made of, whatever pigmentation is going into the skin, the chemical pigmentation, it's reflecting, it's bouncing out red, and that gets sent to our brain through our optic nerve after it mixes around with the rod and cone cells, and we learn the name red assigned to that color. That's a usually maddening thing for students to learn, that something is every color but the color that it is. Okay, I think that's about the most basic I can get with this. I don't want this to go on forever because you will be seeing a demonstration on how to mix colors next.